worksheets all the time.
Yeah,
I really like writing worksheets, so
I just think it's an unnecessary amount of time for me to write down the problem.
yeah. All right. Just wait till calculus, where one problem takes a whole page. All right. Today we are looking at quadratic inequalities. So yesterday we basically solved equations, quadratic equations like this. This is solving a quadratic equation. So we can solve this a couple of ways. What's your thought for this one? X plus 5, x minus 5. That means x equals negative 5 for one of the solutions and x equals positive 5 for the other. You could also add the 25 and square root both sides. Just don't forget the plus or minus. So that's the tricky part, remembering the plus or minus, okay? So I prefer factoring when we can. However, so these are where the function is equal to 0, which is what you guys did yesterday. We realized that, hey, when we solve for x, we're actually finding the x-intercepts, also known as the zeros. The zeros of the function, which really means that's where the function has a value of 0. All right, so the y has a value of 0, and that's why we call them zeros. Now, with that in mind, this function is a parabola. Is it an up parabola or down parabola? Up parabola, okay. And with that in mind, today we're looking at inequalities where it doesn't equal 0. So we want to know where it might be greater than 0 or where it might be less than 0. And so we want to know, again, we're thinking about the function values. This point right here might have an ordered pair of like 6, 11. Okay. What's that y value then? 11. Is that a positive or negative value? Oh, it's a positive value for that alpha. Okay, and so a value like down here, like here, the y-intercept. What's the y-intercept? 0, negative 25. And so that y value is negative. So when we look today, we're looking at quadratic functions. We can actually see that based on the graph, where our function is greater than 0 and where it's less than 0. Here, below the x-axis, all of the y values are negative. All of these ordered pairs have negative y values. All of them. Above the x-axis, our y values are all positive. And so you can pretty easily see where we have positive and negative values, okay, for our function, which is what we're looking for today. Okay, so having a graph helps us figure out intervals where functions are positive or where they're negative, where they're greater than 0 or where they're less than 0. So example 1. Solve each inequality and express the solution set in interval notation.
Yes.
Okay, so first things we want to note here is our function is set equal to 0. Very, very important. We want to make sure that we are set equal to 0. Well, not quite equal to 0. Okay. And so once we're close to 0, then we can factor just like we did yesterday. I can't really solve inequalities. All I can actually solve for is where we're equal to 0. All right, the zero product property allows us to solve for where we're equal to 0. We're actually solving for what are known as critical points. Critical points. Critical points are zeros or places where the function's undefined. So we'll talk more about that tomorrow. What times what is negative 18? Okay, and so if we were to actually solve for where we're equal to 0, you would get x equals positive 9 and x equals negative 2. So these are the function's zeros, okay? In other words, where our function is actually equal to 0, at positive 9 and negative 2. Is this an up parabola or a down parabola? Up. Okay. So I'm just going to make a little bitty sketch here. Really, really small sketch. What I'm interested in is where our parabola is less than 0. So where is our parabola less than 0? Right. Are you good? Okay. So in between our two zeros, our function is less than 0. Because right here, at our zeros, we're equal to 0. Our function underneath 0 would be negative. All right. So negative 2, 0, and 9, 0 is where we're equal to 0. Everything between is negative, and out here, to the left of 9 and to the left of negative 2 and to the right of 9, our function is up here in positive y value territory. Okay? So what interval, what x values give us answers that are negative?
It would be bracket negative 2.
Parentheses.
Dang.
Oh,
yeah.
It does matter which order they're in. Negative 2 to 9, all of these x values between negative 2 and 9 will give us y values that are less than 0. We're going to use parentheses. How come I'm going to use parentheses at negative 2? Because, yeah, we don't want to include 0. We just want to be less than 0. At negative 2, our value actually equals 0. Okay. So you can test this out. So in your calculators, you can do a lot of things, really. We could test a value like, I don't know, 1. Let's say x equals 1. If I were to test a value, then I would say 1 squared minus 7 times 1 minus 18. And I get a number less than 0. That's negative 24. Well, some negative numbers work. Negative 1 would also yield a negative result. All right, negative or positive 1 out was negative 24. Negative 1 would also give us a negative value. But what happens if I try, like over here, negative 3? If I were to try negative 3 squared minus 7 times negative 3 minus 18, I get a positive y value, a positive 12. Negative 3 outputs a 12, and that's not part of our answer. We don't want that. Okay, we want numbers less than 0. All right, so kind of interesting.
Oh, so you can't go lower than negative 2 and higher than 9?
Exactly. So we only want numbers between negative 2 and 9. Yeah. So this is our answer. X values between negative 2 and 9. All right, let's try another one here. We have 10x squared plus x minus 2 is greater than or equal to 0. Again, we've got a 0 on one side. That's good. I'm going to try and find the zeros. The zeros. What times what gives me 10x squared? 5x times 2x gives me 10x squared. And last times last gives me negative 2. What times what gives me negative 2? Positive 2 and negative 1. Is that right?
Yes.
Negative 2.
Negative 2 and positive 1. How do you know if you did it right? Check the rainbow. 5x times 1 is 5x, negative 2 times 2x is negative 4x, and that's where our positive 1x comes from. So I'm going to set each bubble equal to 0. How do you solve for x? Add 2 and divide by 5. Again, in this bubble, 2x plus 1 gets set equal to 0. How do you solve for x? Subtract 1 and divide by 2. Good. So these are the function zeros. I can make a quick sketch here. Here's negative 1/2, and here is 2/5. I don't care about scale. What's the shape of this parabola, up or down?
It's up.
It's an up parabola. Is that something you could check on your calculators?
Yes.
Absolutely. And so how do the signs go here?
Check it.
Plus, this is where my function is positive. Over here and in between, whoops, is negative land, where our function is under less than 0. And out here we are greater than 0. So what we're asking is, where is our parabola greater than or equal to 0? Where are the y values greater than or equal to 0? Where
On the
are
outsides.
the y values greater than or equal to 0? And that is on the outside of the function here. I like to highlight from this point at negative 1/2, we are equal to 0. Is that correct? And all of these x values to the left of that would produce y values up here in positive y territory. Does that make sense to you? Right here at 2/5, our function is equal to 0. And everything to the right, every x value to the right is going to give us y values that are above the x-axis, y values that are positive. So what's the interval this time?
Aren't there two that we have?
There are 2 intervals. Yes, there are 2 intervals.
Negative
infinity to
negative 2. 1/2.
Bracket or
Bracket.
parenthesis.
The bracket.
Very good. We're going to use a bracket here.
U.
How come we're using a bracket at negative 1/2?
Because it is.
Because it's less than or equal to.
Yeah, because it's equal to. We're interested in where it's equal to. Very good. All right. And then what's our other interval?
2/5.
2/5 with a bracket all the way to
Infinity.
positive infinity. Very good.
Yeah.
And then we put a little union in the middle. U for union, and that means to join together.
So I knew that I was doing it.
So, are you trying to solve using an inequality symbol here? You cannot. Right. We cannot solve a higher order inequality. We can only solve equations that are higher power.
Isn't it 2/5?
Isn't it? Sorry, 2/5. Yeah.
What do you mean arguing about the parentheses?
So you always solve an equation
It's more Jackie.
and then make a sketch to figure out where is our parabola greater than 0. You have to actually look at the graph to see it. Yeah.
Let's say we were
Jacob, did you have a question? So there's another way to do it. I prefer the looking at the graph method, okay? But there is another way. Which I will show you soon. They will get more complicated, like D.
Oh, yes.
All right. the graphing is a good way to go. But you can also graph on your calculator, so maybe you don't have to draw a graph, but I would. All right. So letter C, x minus 1 times x minus 2 is greater than x plus 7. What do you think we need to do? Set it equal to 0. So in order to set it equal to 0, what do I need to do with this stuff?
Oh my gosh. We need
Yeah, you got to multiply that out. There's no other way. So we're going to go ahead and distribute. First times first is
to square
the outside,
2x.
positive 2x the inside, and last times last. So I have x squared plus x minus 2 is greater than x plus 7. And as you said, we need it set equal to 0.
So subtract x and 7.
And so if I subtract the x, they go away.
And that's negative 9.
So x squared minus 9 is greater than or equal to 0. So again, this is what I'm trying to figure out. What we cannot do is I cannot solve a quadratic inequality. And so we have to solve the related equation. So we can only find zeros. All right. So I'm going to try and factor, which factors as?
Plus 3 and 9.
X
Yeah,
plus
good. So we can only find where it actually equals 0. That's easy to do. So we know x equals negative 3 and x equals positive 3 are the function zeros. And the shape of this parabola is, again, an up parabola. And so it's pretty easy to see here. To the left, we are in positive y territory. In between, we're in negative y territory. And then back here, we're in positive y territory. So we want to answer this question. Where is my parabola greater than? Where does it have values greater than 0? Yeah, out here. Negative infinity to negative 3. Bracket or parenthesis? Parenthesis. Good. Union. Sorry, thank you. From where else? 3 all the way to infinity. Yes. Okay. Let's do one more. Do you want to learn the other method, or do you just wait till tomorrow? I have to show you tomorrow. Okay.
Well,
All right.
if it's less to write on paper,
Oh, I hate it.
so
I hate
more
it.
to write.
I think so. I think it's more confusing. Well, we'll do tomorrow. Well, I'll save it till tomorrow.
Just wait till tomorrow.
All right. It's called a sign chart. I hate sign charts. All right. What should we do over here with letter D? Take out an X. Take out an X. What's up behind?
X squared.
X
2x.
squared minus 2x minus 24. And again, I cannot solve higher order inequalities. I cannot do it. We can only solve the related equations and go from there. Okay? So how does this double bubble? X minus 6 and x plus 4, which means we get x equals 0, x equals 6, and x equals negative 4 for our function zeros. 0. Okay, what's the shape of this guy?
It's
a squiggle. All right, it's a little squiggle. And where does it begin? On the left, high or low? Low. Starts low and increases, ends up high. So it passes through each zero. So this is kind of an interesting one. So again, we want to know, where is this squiggle? Where is this squiggle less than or equal to 0? Less than or equal to 0 means negative, right? So what are our signs for this? To the left of -4, are we a positive or negative land? Negative land. Our graph is below the x-axis.
Then
So
the next little bump is positive.
the bump is a positive land. Very good. The valley is negative land, and to the right is positive land. Oh, that's why I have this one in here, so you can see more. Yeah. All right.
So it's a lot to write here for that.
All right. So now we want to know, where is it less than or equal to 0? So where is it negative? So negative land is everything to the left of -4. So negative infinity to -4. A bracket or parenthesis at -4? Bracket. Why do we use a bracket?
Because it's less than or
Equal to. Since we're allowed to equal 0, we want to include that 0. Union. Where else is it less than 0?
0.
0 to 6. Right in here. Brackets or parentheses?
Right.
Brackets. Very good. All right. 0 to 6. And there is all of the x values that are going to give us results that are less than or equal to 0. Okay. All right, ladies and gentlemen. Do you have any other questions for me?
Do you expect to see graphs on this piece of paper?
Small ones? I mean, they can be really small.
Also, can I see example A just real quick?
All right, ladies and gentlemen. Skip 22.
I broke it.
Oh, I see. So depending on the sign, we're going for where y values are greater or less than.
Yeah.
Okay, so that's a B. Okay, thank you.
Can I get the Josh?
That's persist 56.
Yes.
I got myself.
Oh, is that right? One of my
19, 6.